Okay, students, good morning to all of you, Nana. So here we are solving objective problems, no? Yes, I'm sharing your material. Sorry, not this. Yes, it is. And we were solving which question, Nana? 78 is over, no? Sorry, 58 is over. Now 59, Nana. No? Yes. 58th answer what, Nana? See 58th question. In Young's double slit experiment, they are asking in Young's double slit experiment, a mica sheet of thickness T and refractive index mu is introduced in the path of ray from a first source S1. By how much distance fringe pattern will be displayed? So this is a formula. Is there a shift in the fringe pattern? And that formula is capital D by small d into mu minus 1 into T. This is direct formula. Use this. You have to remember this. Why, sir? See, in Young's double slit experiment, there are two slits will be there, S1 and S2. No, means small holes. Now, here there is a screen will be there. This is your screen, Nana. Clear? Now, this is a central maxima. Here will form. Now, let us imagine if we keep one sheet having a thickness T and refractive index mu, then central maxima will shift somewhat up. How much it will shift? This is your question. Clear? Because of this glass slab, there will be a path difference. That path difference is mu minus 1 into T. Do you know? Yes. And this path difference can be written in the form of y small d by capital D. This is already we know is equal to mu minus 1 into T. Then y value shift in the distance will be equal to mu minus 1 into T capital D upon small d. Yes, this is only what I have written here. Here, yes, capital D by small d mu minus 1 into T. Yes, option 2 is right answer. Got it, students? Very important question for especially for NEET students and JEE students. JEE and NEET students, important question, Nana. You need to remember this. And on this numerical problems also you may get. Next question number 59. In Young's experiment, light of wavelength 6000 angstrom is used to produce fringe of width given 0.8 millimeter at a distance of 2.5 meter. Okay. If whole experiment is set up is deep experiment is deep in a liquid of refractive index 1.5, then what happened to the fringe width? Do you know fringe width formula? Fringe width formula beta is equal to lambda capital D by small d. Clear? Now, when the whole experiment is immersed in a liquid or any other medium, capital D value, small d value remains same. They will be fixed. That means beta value directly depends upon lambda only. Clear? Yes. Now, initially beta value they have given 0.8 millimeter and lambda value they have given 6000 angstrom. Now they are not changing lambda. What they are changing? They are changing the refractive index. When they change the refractive index 1.6, then your new lambda becomes lambda by mu, Nana. Do you know that? Clear? So due to this, your fringe width will decrease by beta by mu. Are you understanding? Directly I am saying. Because lambda, it becomes lambda by mu. So fringe width also becomes, see, fringe width becomes beta is equal to, I'll write total formula so that you'll understand. Beta is equal to what, Nana? Beta is equal to lambda dash capital D by small d. Yes, lambda dash will become lambda by mu capital D by small d. This lambda capital D by small d is what? Initial fringe width divided by mu. Clear? Yes. So initially given 0.8 mm and now mu value given 1.6. So what will be the value of this? 0.8 by 1.6 can be written as 8 by 16. Correct? Yes, multiply and divide with the 10. Here and 10, here 10. You will get 8 by 16. 8 ones are 8, 8 twos are 16. 1 by 2 means nothing but 0.5 mm. 0.5 millimeters. Got it? Yeah, where option? Yes, first option only there. First option is 0.5 millimeter given. Yes, perfect answer. We got. Clear, students? Understood all of you? Okay? Clear? "19 students are there." Important question, and this is also especially for NEET students important. Next, question number 60. I am going to question number 60. What they have given, Anna? If a transparent, they have given that if a transparent, question number 60, no? I'll take to question number 60 directly. Yes. They have given that if a transparent if a transparent medium of refractive index mu is equal to 1.5 and thickness 2.5 into 10 to the power of minus 5 meter inserted in front of one of the slit, okay, how much will be the shift in the fringe pattern? The distance between the slits is 0.5 and between slit and screen is 100. Okay, so they are given that mu value how much, Nana? 1.5. Okay, and thickness also they have given another 2.5 into 10 to the power of minus 5 meters. Okay, next what they are given? Distance between the slits means small d value given. How much? 0.5 mm. You need to be careful. 0.5 mm can be written as 10 to the power of minus 3 meters. And distance between the slits and screen is 100 centimeter. Capital D is equal to 100 centimeter given. We know that 100 centimeter is equal to 1 meter. Here, yes, it is 1 meter. Okay. Now, what are they asking? What is the shift due to this glass slab of thickness? Shift formula is mu minus 1 into T capital D by small d. Direct formula, substitute the values. This is value substitution question. Direct. Okay. Yeah. So mu value is 1.5 minus 1 into thickness is given 2.5 into 10 to the power of minus 5 into capital D given 1 meter upon small d given how much, Nana? Small d given 0.5 into 10 to the power of minus 3 meters. This cancel. Okay, and here in thickness 1 meter is there. Here meter is there, so that you will get answer in meters. Okay, 1.5 minus 1 is 0.5 into 2.5 into 10 to the power of minus 5 meters upon what is this value? 0.5 into 10 to the power of minus 3. Okay, 0.5 0.5 cancel, na? 10 to the power of minus 3 cancel with 10 to the power of minus 5, you get minus 2, means 2.5 into 10 to the power of minus 2 meters. Now check options. Okay, 2.5 10 to the power of minus 2 meters can be written as centimeter, 1 centimeter. No? Yes, 10 to the power of minus 2 means 1 by 100. Here? Yes, 1 centimeter is equal to 10 to the power of minus 2 meters, correct? Okay, means answer is 2.5 centimeters. See, 0.25 centimeter also they have given. You should not get confusion. Option 2 is only right answer. Got it, students? Okay, here. Okay, now next question number 61. I am going to question number 61 now. See, question number 61 in Young's experiment. Good. They have given that in Young's experiment, monochromatic light is used to illuminate two slits A and B. Okay, interference fringes are observed on the screen placed in front of the slit. Okay, now if the thin glass plate is placed normally in the path of a beam coming from the slit, then what happened, Nana? This fringe width, which side this glass slab is there, that side it will shift. Okay, yeah. So see options what they are given. The image will disappear, the fringes will disappear. No, images fringes will appear. Wrong. Fringe width decreases. No, fringe width doesn't decreases. Fringe width remains same. Point is important, remember. Next, fringe width increases. No, doesn't happen, right? Nothing will happen to the width of the fringe. There will be no change in the fringe width. There will be no change in the fringe width they have given. Wait. Options. All the options I'll take one more time. Question number 61. No, no. Yes. So question number 61. See last option. See, there will be no change in the fringe width. Yes, this point only I am saying from first onwards. Yes. Fringe width does not changes, whereas this central maximum will shift upward somewhat. How much it will shift up? Mu minus 1 into t into capital D by small d. This much it will shift up. But fringe width of the fringes, how many fringes, how much width distance it will form, that width doesn't changes. Width of the fringe remains same. Remember this point. Question number 61 is over. Next question number 62. Question number 62, what they have given? Question number 62, the central fringe of interference pattern produced by light of wavelength 6000 angstrom is found to be shifted by a position of fourth bright fringe. Okay, after the glass plate mu is equal to 1.5 is introduced, then thickness of the glass slab. Okay, now see here this one, when this glass slab is introduced, there is a shift. Up to here it came, so this shift is given equal to how much, Nana? Fourth bright fringe. Up to what they have given, the shift is given is equal to fourth bright. So what is this fourth bright? Y maximum is equal to n lambda capital D by small d. Do you know, remember? Yes. So n becomes 4. So 4 lambda capital D by small d is the distance. It is shifting, and this shift is due to this. Means this shift can be written as mu minus 1 into t into capital D by small d, we can write. Okay, is equal to 4 lambda capital D by small d. Got it? Is equal to this. So what will happen? Capital D by small d cancel. We want only thickness. So thickness t will become 4 lambda divided by mu minus 1. Nana. Yes, 4 into lambda given how much? 6000 angstrom. Upon mu value is given is 1.5. Yes, 1.5 minus 1. So thickness t becomes 4 into 6000 into 1 angstrom is equal to how much, Nana? 10 to the power of minus 10 meters. No, yes, I am writing. Upon 1.5 minus 1 is 0.2. Correct? Yes. So it becomes 0.2. Means 2 ones are 0.1. It is 2. Yes. So 0, it will become say someone is writing don't do that. So it becomes what, Nana? So 0.1 is there here. 0.1 means what, Nana? 10 to the power of minus 1. Means this will cancel with 10 to the power of minus 9. It will become, yeah. So 6 2s are 12 into this 3 will cancel with 10 to the power of minus 9. Means it will become 10 to the power of minus 6 meters. Means, sorry, It becomes 12 micrometers answer. Okay, but option is 4.8, 8.23, 14.98, 3.78. Okay, where what is there given? Central fringe of interference spectrum produced by light of wavelength 6000 angstrom is found to shift to the position of fourth bright fringe. Fourth bright fringe position is fourth bright fringe position is 4 lambda capital U small d. Yes, correct. Fourth bright fringe position value how much nana? 4 lambda capital U small d. Is correct. Then shift due to that glass slab is mu minus 1 into t capital U small d. Yeah, 4 lambda by mu minus 1. Mu is 1.5 given. 1.5 minus 1 is 0.5. 0. Yeah. See here, calculation mistake. Nana. See here. See here. This mistakes. I'll write one more time. Instead of writing 1.0.5 I have written, okay, so 4 into 6000 into 10 to the power of minus 10 upon 1.5 minus 1 is 0.5. No, I have written 0.2. That is a mistake. Okay, yes. So what we will get, see, 3 zeros cancel with 3 0, it will become 7. Okay, so we can write 4 into 6 into 10 to the power of minus 7 divided by 0.5, means 5 into 10 to the power of minus 1 we can write. So 10 to the power of minus 1 cancel with 1, you will get minus 6. Okay, so 6 into 4, 24. Okay, your value will be 24 upon 5, 10 to the power of minus 6 into 10 to the power of minus 6 meters. 10 to the power of minus 6 meters is micrometer, we can get. So 24 divided with 5, you'll get 5 4s are 20.40 is 5 8s are 40 is 4.8 micrometer is perfect. Option 1 is there. So previously I have written 0.2 here by mistake. It is 0.5. Yes. So answer is 4.8 micrometer. Got it, students? Clear? 62 question number. Option 4.8 micrometer is right answer. Clear? Next. Question number 63. Let us go to question number 63. So question number 63. They have given in Young's double slit experiment, a slab of thickness 1.2 micrometer and refractive index 1.5 is replaced in front of one of the slit. Another slab of thickness T and refractive index 2.5 is placed in front of the second slit. If the position of central fringe remains unaffected, then thickness is. If this position is unaffected, means how much this is shifting. Same thing, it has to shift. Means shift due to first one, mu1 minus 1 into T1 should be equal to shift due to second one, means mu2 minus 1 into T2. This is the thing, it has to happen. Okay, now here T2 value what they are asking Nana. Yeah, so mu1 value given 1. How much? 1.5. Yes, mu1 is 1.5 given, minus 1 into T1 given 1.2 micrometer is equal to mu2 value given 2.5. 2.5 minus 1 into this thickness they are asking. Okay, 1.5 minus 1 is how much? 0.5 into 1.2 micrometer is equal to 2.5 minus 1 is 1.5 nana. 1.5 into T2. Here, yes. Then what is your T2? T2 will be 0.5 into 1.2 micrometer upon 1.5. Yes. So this will become how much? 12. Okay. 0.5 ones are 0.5, 0.5 threes are 1.5. Correct? Yes, perfect. 5 threes are 15. No. Yes, point will cancel here. Okay. 3 divided with 1.2, you will get 0 point, means 12 it will become. 3 divides 12 how many times? 4 times. 0.4 unit is micrometer. Yes, answer is 0.4 micrometer. Where is the first option only is there? 0.4 micrometer. I hope you understand this. Calculations only you need to be perfect. Whereas this concept you already know. I already explained this concept. Clear? Yeah. 63 is over. Next. Question number 64. Question number 64, Nana. What they have given? See, in YDSC experiment, the fringe width is 0.2. Okay. Fringe width beta is equal to how much, Nana? 0.2 millimeter given. Next. If the wavelength of light is increased by 10%, means wavelength of light lambda dash is equal to from initial wavelength increasing by 10% of initial wavelength. That is the meaning. See, you need to write, this is the point important I am saying. If the wavelength is increasing by 10% means from original wavelength 10% is increased. That is the meaning. Okay. And separation between the slits is increasing by 10%. Okay. Separation between the slits is capital D. See, this capital D also increasing by how much? 10% of capital D. Then what they're asking? Then what is the new fringe width? What? Due to these two changes, what is the new fringe width? Question mark. Okay. So lambda dash what, Nana? Lambda plus 10% means 10 by 100 lambda. Correct? Yes. So it will become 0, 0 cancel. You'll get 10 plus lambda by 10 means 11 lambda by 10. Okay, now these calculations you are having lambda plus lambda by 10. LCM is 10. Cross multiply. Lambda into 10 is 10 lambda plus lambda. So 11 lambda by 10. Got it? Yes, I have written directly. No problem. You know this because you are studying second PU, you know. Clear? Okay. Then what is D dash, Nana? D dash value is also same, capital D plus 10 by 100 of capital D. 0, 0 cancel. It will become again 11 capital D by 10. Correct? Yes. New fringe width. Fringe width due to this fringe width formula, what, Nana? Fringe width beta is equal to lambda capital D by small d. Small d, however, it is not changing. Correct? Small d is not changing. Okay. Now beta dash become what, Nana? Beta dash become lambda dash d dash upon small d. Correct? Yes. What is lambda dash? Lambda dash is 11 lambda by 10. Capital D how much? 11 capital D by 10 upon small d. Yes. So this becomes, I am writing here, beta dash become 11 into 11 how much, Nana? 121. Yes, 121 divided by 10 into 10 how much? 100. It can be written as lambda capital D by small d. Yes, lambda capital D by small d I am writing. So beta dash become 121 by 100. Lambda capital D by small d is what? Original fringe width. Okay. So beta dash become 121 by 100 into original fringe width is given 0.2 millimeter. Clear? Yes. See, option is in millimeters only. Okay. So unit is not changing. Okay. Now just you need to calculate this total thing. So beta dash become 0.2 into 121 become 2 ones are 2, 2 twos are 4, 2 ones are 2. After one digit point divided by 100 millimeter. So 24.2 by 100 becomes 0.242 millimeters. Correct? Yes. 0.242. Yes, option 4 is there. Perfect answer. Calculations need to be correct now. Okay. And JEE students, listen, JEE students, you may get this type of questions for your what? Integer type questions. Integer type questions you may get, Nana. JEE students, be careful. Got it? Question number 64, answer is this 0.242. Clear? Next, question number 65. 65, what they are given? A very thin, they are given that a very thin transparent film of soap solution, thickness is almost 0. is seen under reflection of white light. The color of the thin film appears to be black, Nana. See, under reflection, first, see reflection phenomena, where maxima will form, where minima will form. Due to that, minima is nothing but darkness, so it will become black. Remember this conceptual question. Next, question number 66. Question number 66, they are given that in Young's double slit experiment, if monochromatic light is replaced by white light, then what happened? Central fringe will be white color, and that white central fringe will be surrounded by, this is the central fringe. Central fringe will be white in color, Nana, and this will be surrounded by remaining maximas. First maxima, which color will form? First maxima, blue color will form. Last maxima will be red color. Do you remember that all points? Okay. Yes, see here, option 3. Only central fringe is white, all the other fringes are colored. This is the answer, 66. Next, question number 67. Question number 67, they are given that if the fringe width in Young's double slit experiment is increased. So when fringe width in Young's double slit experiment increases, see here, fringe width formula beta is equal to lambda capital D by small d. So this has to increase, means lambda has to increase, or capital D has to increase, or small d has to decrease. Now see, wavelength increases, yes, correct. Next, distance between the slits increases, yes, correct. Sorry, distance between the slits means small d increases, means wrong. Distance between the screen and source and screen, capital D, decreases, wrong. Frequency of incident light increases, so frequency does not change the fringe width, Nana. So thing is, option 1 is right answer. Option 3 also becomes right when it is increases here. Option 2 also becomes right when decreases here. Be careful. This type of questions you will get in conceptual direct questions. Remember, students, 67 over. Next, they are given. Next, so this YDSC are more frequently they are asking us. So that's why I am discussing more on this topic. Next, otherwise I'll give homework only. I'll make maximum points, similar points. 68. Young's double slit experiment is performed with white light of wavelength 550 nanometer. The separation between the slits is okay. Lambda given. I'm entering the data 550 nanometer. Separation between the slits means small d given 1.1 millimeter given. Okay. Screen is placed at a distance of 1 meter, means capital D is equal to 1 meter. What they are asking, what is the distance between consecutive bright or dark fringes? Consecutive bright or dark fringes is nothing but fringe width, and the formula is lambda capital D by small d. Substitute, you will get the answer. Substitute these 3 values, you will get the answer. Okay, na? Clear? Yes. 0.5 millimeter is the option, Nana. Do this. Direct substitution question, right? Next, 69. In Young's double slit experiment, for which color fringe width is least? See, fringe width depends upon wavelength lambda. Okay, fringe width should be less, means wavelength should be less. Wavelength will be less for among VIBGR, VIB, GYOR. Wavelength is increasing like this. Maximum for red, least they are given green, blue, yellow. So which color is first? We are getting blue color. So blue color is having lambda minimum. Clear? So green color, blue color fringe width will be very less. Important question. It is a repeated question in your competitive exams, CET, NEET also. Clear? Okay. Next, question number 70. Question number 70, Nana? What they are given? Question number 70, they are given that if sodium light, what is sodium light? Sodium Sodium light is nothing but yellow color light, yellow color. Remember the point. Okay, now what they are doing, sodium light in double slit experiment is replaced with red light, then fringe width. Yes, sodium wavelength means yellow color wavelength, VGR. Yellow color wavelength is less, lambda for Y is less than lambda for red. Okay, yeah. Now when the red lambda is replaced with red light, means lambda value is increasing, then what happened to beta, fringe width? Fringe width also increases. When lambda increases, fringe width also increases. Clear? Yes, option 2 is right answer. Then fringe width, what will happen, they are asking. So yellow color, if you replace yellow color with red color light, that means you are increasing the wavelength. When wavelength increases, fringe width also increases, because fringe width is lambda capital D by small d, direct proportionality. Next, question number 71. A double slit experiment is performed with light of wavelength, how much? 500 nanometers. A thin film of thickness, how much? 2 micrometer, and refractive index 1.5 is introduced in the path of upper beam. The location of central maxima will be, see, if the slits are here like this, and here upper slit one glass slab introduced, then central maxima will shift upward, it will shift upward. Clear? So remains shifted, wrong. Shift downward, wrong. Shift upward, yes. Shift downward also wrong. See, shift upward given, and nearly 2 fringes they are given. If suppose if fourth option is also shift upward 4 fringes, then you will get a confusion. What answer you have to find? See, number of fringes shifted will be equal to mu minus 1 into T by lambda, Mu value is given 1.5 minus 1 into thickness is 2 micrometer 10 to the power of minus 6 upon lambda 500 nanometers 10 to the power of minus 9. Okay, yeah. So these calculations become 0.5, 1.5 minus 1 is 0.5, 0.5 into 2 into 10 to the power of minus 6 upon 500 into 10 to the power of minus 9 means 5 into 10 to the power of minus how much? 7. Correct? Yes. 5 ones are 5, 5 0.1s are. So these are, because of this 0.1, it will become 10 to the power of minus 7. 10 to the power of minus 7, 10 to the power of minus 7 cancel. It will get 2 exactly. Means how many number of fringes will shift upward? 2 fringes shift upward. Yes, perfect answer. Option 3. Important point, remember how many fringes shift upward? Formula. Formula what? How many fringes? Number of fringes shift upward. Formula is mu minus 1 into T upon lambda. Whereas shift formula is mu minus 1 into T capital D by small d. This is the shift formula. This is how many number of fringes will shift. You have to remember these are formulas, otherwise you can't remember, you can't find the answer. Okay, yeah. Next, question number 72 is there. Question number 72, they have asked that in YDSC experiment, when 2 light waves makes third minima, then they are, see, they have to 2 light waves, they have to make a third minima. So for minima, okay, what they're asking first, phase difference they are asking, phase difference and path difference they are asking. So for minima, we know phase difference delta phi is equal to 2n minus 1 into lambda by 2. Yeah, this is for path difference, delta x. Path difference is 2n minus 1 into lambda by 2. This is a path difference relation. Okay, so which minima? Third minima you want. Means keep 3 there. 2 into 3 minus 1 into lambda by 2. What you will get? 2 3 is 6, 6 minus 1 5. So 5 lambda by 2 should be there. What path difference should be? 5 lambda by 2. Yes. Where is it here? Here. Path difference is 5 lambda by 2. This is perfect answer. Sometimes they may have double answer also. More than one option also will be there. They are given phase difference also. No, let us check. We know the phase difference and path difference relation is delta phi is equal to 2 pi by lambda into delta x. Okay? Yes. 2 pi by lambda into delta x value is just now we got 5 lambda by 2. 2 cancel, lambda cancel. We'll get 5 pi. 5 pi given or not given? Not given. So wrong. So only option 4 is given answer. Got it, students? Important question. You may get this type of questions also. Remember. 42 over 73. 72 over 73 now. So yeah. 73 question, 3 minutes time is there. Let us solve. If in a Young's double slit experiment, width between slit is 3 meters, 3 centimeters. Width between slits is nothing but slit width. How much na? Means fringe width is 3 centimeter. And separation between the slits small d 7 centimeter. Wavelength of light capital D lambda is equal to 1000 angstrom. Sorry, and they're asking fringe width. Wait, width between slits is 3 centimeter. Sorry, width between slits it is small d nana. Width between two slits they are given. Width between slits is 3 centimeter small d. Separation between slits and screen 7 centimeter capital D it is. Separation between slits and screen is capital D 7 centimeter. What is fringe width? Direct formula lambda capital D by small d. Substitute lambda value, capital D value, small d value. Substitute, you will get the answer. Lambda 1000 angstrom into capital D 7 centimeter, small d 3 centimeter. Centimeter cancel, you will get 7000 angstrom by 3. Convert the answer into meters or millimeters, you will get the answer. Okay. Yeah, so 2.3 into 10 to the power of minus 7 meters an answer you will get. Yeah, okay, no? Clear? And students, this coming Saturday you are having objective test and subjective test on wave optics chapter. Already I have given all the important questions for you for your homework. You read all of them, and to get out of marks you need to read total chapter also. And prepare these objectives clearly. If you prepare these objectives clearly, then you can solve, you can give the answers for whatever the questions I will keep for your exam. Prepare well, Nana. This is important chapter. Weightage is very good. Weightage is there for this chapter. Numerical problems also they will ask for your board exam, Nana. Prepare well. Got it, students? Yes. So one more question is there. Let us solve. Why time is there? 1 minute. 74, question number 74. They have given that. What they have given, Nana? A monochromatic beam of light is used for the formation of fringes on the screen by illuminating the two slits in Young's double slit experiment and Young's double slit interference experiment. When a thin film of mica is interposed in the path of one of the interfering beams, then fringe width increases. No, wrong. Fringe width doesn't increases. Fringe width remains same. So this is wrong. Next, fringe width decreases. Wrong. Fringe width remains same, but pattern shift. Yes, third answer is perfect. Pattern shift. Third answer is perfect. Fringe pattern disappear. Wrong. Third option is perfect. Clear, students? Okay. Yeah. Thank you. In remaining problems, we will continue in next class. So 74 is over. We'll continue in next class. Bye.